We don't know AI agents are the future, right? They promise to do everything for us, manage our calendars, even write our code. But what happens when all that power gets turned against us? Today, we're going to break down a real-world security test that showed just how fragile these new systems can be. So, picture this. A security firm starts a timer, just 30 minutes for each target. They're looking at 16 brand new AI agents, all from companies in the super prestigious Y Combinator accelerator. And in that tiny window, they successfully hacked 7 of them. That's a nearly 50% failure rate. It shows us there's a huge, critical new frontier in cybersecurity that we've got to pay attention to. So why'd they do it? Well, René Brandl, the CEO of the security firm Casco, he put it pretty bluntly. They wanted to make a splash. And by ethically hacking their own peers, they created this unforgettable demo of a really big, growing danger. And in the process, they got the second highest rated launch post in YC's entire history. Not bad. Okay, so what all this really highlights is a massive misunderstanding about AI safety. The real risk, it turns out, isn't just about tricking the AI model itself. No, it's about the entire system that's built around it.
You know, most of the security talk out there is focused on what you see on the left, LLM security. We're talking prompt injection, trying to get the AI to say bad things, basically messing with the AI's brain. But what these hacks really exposed is the critical importance of what's on the right, agent security. It's not just the brain, it's the whole body, the entire tech stack, all the tools it can use, and all the sensitive data it can touch.
I mean, just look at a typical agent stack. It's basically a chain of trust. It goes from your input, through a server, to the LLM, and then it reaches out to tools and data sources. Now, an attacker doesn't need to break the strongest link in that chain. They just need to find the weakest one. And as we're about to see, there are plenty of weak links to pick from. The security team found 3 recurring flaws that were just devastating. And honestly, you should think of this next part as the actual playbook for how these digital heists got pulled off. It all starts with a classic vulnerability, just in a totally new context. Okay, flaw number 1. It's a mouthful. Insecure Direct Object Reference. We just call it IDOR. But the concept is actually really simple. Imagine an app checks that you have a key to get into an apartment building. Great. But it doesn't check if your key is for apartment 101 or 201 or 301. So you can just try other doors. And that is exactly what happened. The attackers found a user ID just sitting in the URL of a public demo video. A public video. They just took that ID, fed it to the agent, and the agent, just trying to be helpful, pulled up all of that user's private info. And from there, they could see that user's chat IDs, their document IDs, basically giving them a full map to all their data. And the real danger here wasn't just about one little piece of data. No, because everything was all connected, that one single exposed ID let an attacker literally walk through the entire system, linking together a person's identity, their private chats, and all of their documents. Let's move on to the second flaw, which honestly is even more dangerous, the code sandbox escape. So a lot of these agents use sandboxes to run code safely. It's kind of like a padded cell for code, right? It's supposed to be secure. But what happens if the code figures out how to pick the lock and escape into the main build? The cleverness of this attack is just astounding. The hackers didn't use some brute force thing. Nope. They simply prompted the agent and got it to reveal a hidden tool that could write and read files. With that, they mapped out the whole server's file system like a blueprint, found the main security file called app.py, and then just overwrote all the security functions with empty code. They effectively erased all the locks. And once they escaped that sandbox, it was game over. They could move laterally, just wander through the company's entire internal network, discovering other services, grabbing powerful access tokens, and eventually getting access to the company's entire cloud environment. The results, in the very, very understated words of the researcher, whoopsie, we have access to all their customer data. Just think about that. A tiny flaw in a simple code tool led to a catastrophic full system breach. All because that sandbox wasn't really secure. The third and final major flaw they kept finding was server-side request forgery, or SSRF. Now, this is a really sneaky one. This is where an attacker tricks your own server into becoming their unwilling accomplice, making requests to places it should never, ever be talking to.
So, for instance, an agent had a tool that was designed to pull some data from a private GitHub repository. The attackers just replaced the legitimate GitHub URL with a malicious one that they controlled, and when the server tried to connect, poof, it sent its private GitHub credentials right to the attackers, and they then used those credentials to download the company's entire private source code, the whole thing.
You know, when the hackers told their fellow YC founder about this huge breach, the response was immediate and just very human. Don't worry, bro, it's already fixed. It just goes to show you how fast these teams scrambled to patch the holes once they were pointed out. So after witnessing this whole digital heist, what's the debrief? What do we actually learn? Well, this brings us to the AI security playbook. 3 core rules to protect your own AI systems. Okay, the playbook really boils down to 3 critical rules. First, you've got to shift your focus. Agent security is so much bigger than just LLM security. Second, and this is key, you have to treat agents like users, not services. And third, and this is a hard truth, you should almost never try to build your own code sandbox.
The most important mental shift here is this. An agent acts on behalf of a user. That means it should only have the permissions that that specific user has. Way too many developers are giving agents these God mode service level permissions, and that's exactly what lets a tiny little breach turn into a total system compromise.
And finally, don't get so caught up in the new, shiny AI tech that you forget the old lessons. Basic web security hygiene, sanitizing inputs, validating outputs. That stuff is just as critical for AI agents as it was for websites 20 years ago. The fundamentals still matter a lot. So this leaves us with one final, critical question to think about. Your AI agent, it has access to powerful tools, sensitive data. So you have to ask yourself, have you given it only the permissions it means to do its job? Or have you accidentally handed it the keys to the entire kingdom?